All right, guys, welcome back to the channel. We are finally getting back into this apartment, and I hope you watch till the end. This is a very, very long video, but there's a lot of good information here. If you can't, well, just chop it up and then watch it over a couple days. But let's take a look. All right, here we are. We are back. We're back in the apartment. This is the area that I showed you, kind of that video about doing it the fast way. So here we are. Okay. Now, let's just say you got called out to this place. Homeowner calls you, said that they needed heating and air conditioning put in here, ductwork, the whole 9 yards. We are going to walk through how to do it start to finish. Okay. So, very first thing, when you go out to do one of these load calculations, what do you need? Well, you're going to need a few things. I would first get yourself very familiar with whatever program you're using or the software that you're using to do your load calculation. Let's hypothetically say you're doing it pen and paper. Become very familiar with everything that you need to know going into the thing so you're not kind of stumbling around and fumbling and yeah. So we get here. This is what I usually bring with me. I got some paper, okay? Also, bring literature, okay? If you're dealing with Train, if you're dealing with Carrier, if you're dealing with Daikin, Heil, whatever, I don't care what brand you're using, bring some of that literature along with you. One, to share with the homeowner so that they can look at it while you are doing your thing. Bring some pictures of installs that you did, so that they can look at those while you're roaming around their house. But also the manufacturing data, okay? So what your blowers are operating against, anything that's pertinent, sizing, okay? The size of your condenser. There are some, you get out next to a building, they've got some shrubbery around there, and you think, oh yeah, that'll fit. And then you bring that 20 SEER air conditioner in there and you're like, oh gosh, I probably should have known that this wasn't going to fit. These condensers are getting bigger and bigger and bigger every year. So to have those dimensions with you while you're out doing your site visit is great. So I'll bring that along with me just so I know, okay? So we've got some good old graph paper, okay? We've got a pen we've got a pen. I usually will bring a few different pencils with me, and we need a measuring tape. If you really want to speed it up, laser distance measurer, that'll really help you out. So what I usually do first, while I'm letting the homeowner take a look at any literature I may have, pictures, whatever, I'm going to start walking around the building and just getting familiar with the layout of the building. So do a exterior walk. Now, what I'm looking at on the exterior of the building are a few different things. The siding, I'm looking at the windows, the condition of the windows, the condition of the house in general, the roof, the type of material that the roof is made out of, shingles, metal, whatever. Is it a flat roof? What kind of a pitch is that roof at? These are all things that I need to know, and I will be jotting those down. Now, today, I am not going outside this building because, oddly enough, it is like a monsoon here in Pennsylvania today, which is really strange, but hey, we're going to go inside today. Tomorrow it's supposed to be nice. I'll probably come back and film the exterior portion of what a site visit is. But we've gone around the outside. We've looked at everything. Now we're going to come inside the house and look at what we're doing in the house. So as opposed to working with the paper there, what I'm going to do is I'm going to draw everything out on this to show you what I would be drawing in my little scratch pad there. So this doesn't have to be drawn to scale. Remember, you don't want to be in here too terribly long. If you're in doing a load calculation on you want to get as much information as you can in 60 minutes and then get going, okay? Give or take. I mean, I'm not holding you to 60 minutes, but so what I'll typically do is just familiarize myself with the layout of the building. Now, this one is a very, very easy area. because it's a very small apartment. We're not doing the entire building. We're just doing this apartment here. So what we've got our front door. Okay, this is the door to the outside. This carpeted area, that's all we've got for a living room. Very, very small. I'll measure this out for you, but this is a very small area. Okay, so this is our living room area. Then we've got a kitchen, which actually takes up the bulk of this apartment, oddly enough. But hey, your kitchen is the heart of the home. So this is a nice big kitchen. So yeah, this is our kitchen area. Familiarize yourself with the layout of this. Small dining area, very small, but it's functional. Okay. Then we've got 2 bedrooms in here. Both these bedrooms are similar in size. They're about a 12 by 12. I think this one's an 11 by 12. The other one's a 12 by 12. One window, not too much going on in here. Again, the other bedroom there. And then all we've got is standard bathroom. The reason I call this a standard bathroom is because this bathroom layout is very common in what they would call like guest bathrooms, or I see a lot of these layouts in like master suite bathrooms that don't have jacuzzis or anything like that. This is a 5 by 8, okay? Enough for a tub, a toilet, and a sink, okay? That's a standard small bathroom. So, oh, and then back there we've just got a small little closet slash laundry. That's what I'm thinking of. We've got our apartment. Easy. All right, so I apologize, but for some reason my microphone was not working too well this day. So I'm actually going to voice over the bulk of the rest of this this site visit here. So yeah, let's dive back into it. All right, so we're getting our apartment kind of laid out on the paperwork, and we're just going to go out and start laying components out that we know are here. So like things like windows, front doors, very common items, walls. You want to get all this stuff kind of just laid out. Like I said, it doesn't have to be to scale, but as long as we at least get it on the paper. Unless you have an oddball door, we know what front doors are. They're pretty much a standard 6'8" tall, 34, 36 inch wide, stuff like that. So like here, what I'm doing is I'm putting in the computer, on the piece of paper, pieces of furniture that are not the chances of them being moved are pretty slim. So if you've got a big china hutch, or if you've got a bedroom where you know that the only place a bed is going to go is against this one wall, we don't want to throw a supply duct right under where that bed's going to be. If we've got a china hutch, same thing. A couch, you kind of know where things are going to end up. So I will kind of jot those in my notes just so that whenever we're actually doing our duct sizing, I know where I can and cannot put specific supply and return registers. So as we continue to go through here, we're going to lay out the bedrooms. I do take note to which way the doors do swing, just so I know where I'm putting my returns, because I like to put returns behind where the door swings. So go through, take a look at all the windows, make note of what kind of windows they are. If you've got a casement window, if you've got a double hung window, if it is just a flat panel window, it's non-operable, take note to that. But yeah, so here I'm looking at the kitchen, okay? You want to get a rough idea of where the cabinets are. And I like to take a really good look at the kitchen. Kitchens are kind of difficult because, there's a huge load in kitchens, cooling load in kitchens. And a lot of times we have a hard time figuring out where we can physically put enough air volume in registers to make it work. So be as detailed as you can when it comes to kitchens.
when it comes to laundry areas, when it comes to these high load areas, because we need to know. So yeah, once you've gone through the whole building and just got a rough idea of where the walls are, where the doors are, where the windows are, well, the next step is measuring everything out. Okay, so it shouldn't take you very long to get a rough idea of where all the rooms are. Now, when it comes to measuring everything, this is where you can really make up a lot of time. Okay, if you're out there by yourself with uh, a ruler or a measuring tape, this could take you a while. Okay, and so having a laser distance measure really speeds things up because we're going to be measuring every single wall. We want to know the ceiling area, the floor area. We want to measure every window and every door as detailed as we can. Okay. Now, fortunately, this is an easy apartment, and I just built this apartment 2 months ago, so I pretty much know the size of these rooms. Each bedroom is the one is a 12 by 12, the other is an 11 by 12. So we're going to take a look here. We're going to measure out the laundry area just because I honestly have no clue what it is. And I think it came out to like a 4 or a 5, somewhere in there. So jot that down. Again, we're going to measure out, the the bathroom, the living room, kitchen, dining, every room we need to know. Okay. So I'm going to go through and do that here. When it comes to the building, I want to look at it as not as a zone per se, okay? But I kind of chop things up into zones to where each bedroom is a zone, okay? If I have a laundry, or I'm sorry, I keep saying laundry, a living room and a kitchen and a dining all kind of open. This is very common with a lot of new construction and remodels to where people are just blowing walls out and we're making everything that big open concept. That's what everybody wants. They want you to walk in the front door and be like, oh my gosh, this house is huge. When in reality, it's no bigger than what it was before. But because everything is opened up, it feels bigger. Now, with that, I don't, I wouldn't put we look here, the living room, the kitchen, the dining, this is all open, but I'm not going to stick just one supply in there with a 10-inch flex to supply this whole thing out. I need to look at the living room area as a zone in itself, the kitchen as a zone in itself, because I want to get as much supply to each zone area or wherever our high loads are. That way, we're not feeling a lot of draft to where we're dumping air into one area that doesn't need it and sucking it over towards the kitchen or towards wherever our returns may lie. And so I will kind of chop things up a little bit. Now, it was easy here because the living room, it had a carpet, and again, I just put that carpet in, so I know how big that was. So that I am treating as a zone in itself. Now we're going to measure out the kitchen and dining room area. So we're going to see how big that ends up being. Now, with kitchens and dining rooms, again, you got to be careful because placement of registers and, more importantly, returns can be tricky. I've run into a few situations over the years where returns were placed a little too close to stoves and kitchen areas, and I have some really bad stories about or I guess interesting situations I've been in involving some ethnic cooking and some greasy returns. But anyway, so we're going to take a look at all that. You can see here we've come up with a 16 by 19 general area for the what we're calling the kitchen dining. Okay, so now at this point we've gotten all of our a general dimensions, okay, of the building. And so what I'm going to do is I'm going to start taking a look at the windows and doors. I want to get a good measurement on our windows and doors, so that we can actually put that into our computer, or we can put it on our spreadsheet, or we can even put it in our abacus, and we can figure out what we're doing if that's how you want to go about this. So you can see here, this is what we're actually considering our master bedroom. It's the larger of the two. And what I opted to do, because these rooms are pretty small, I needed to have egress windows, I opted to put casement windows in to meet the egress requirements of these rooms. The nice thing about these windows is they are much smaller than what an egress double hung window is, but you still meet code because that entire panel opens up. So we're going to go ahead and measure these out and see exactly how big they are. Now what you'll notice is whenever I'm going through and actually looking at the window itself, if I'm out at a place, I want to look and see if on the sill or on the window panes themselves, if I can find any manufacturer markings, model numbers, serial numbers, anything like that I can then take and cross-reference. A lot of, I don't know, there's a lot of programs out there that I have used that really don't care. They say a double pane window is a double pane window. And I can tell you that is not the case. Okay, there are actually some very reputable software programs that do that, and that's one thing that I really did like for the time that I was doing load calculations by hand with the old manual J book, that I could be extremely specific in what I deemed as my BTU movement through a sheet of glass. Okay, I could be very specific in my calculation. Now again, that's not all programs. Some you can do this and it works very well, but that's a whole video for another day. Now on these specific windows here, I couldn't find any markings from the manufacturer, whether they were Pella, Anderson, Geldwin, or whatever. I couldn't find anything on these. And I did buy these wholesale to where I was not given any information. So I am going to take a look at the windows, and I'm going to cross-reference them through an old manual D book. I'll put that into my calculation and we'll go from there. So we're just going to continue moving around here, and we're going to take a look at some of these other windows. Now this window here in the dining area is a much smaller window. Okay, this is actually a wood cased window. The last one was vinyl. That's something you want to take note of. Okay, I don't really know that residential does any aluminum framed stuff anymore. I could be wrong. Maybe they do out towards like the shore, but in my area, I'm not seeing aluminum framed residential windows. Now I do see them almost every commercial job that I'm on, and as a matter of fact, if you look out this window here, the building directly behind me is an aluminum window frame manufacturer. They make aluminum frames for commercial windows all over the country. So yeah, we're looking at this. As you can see, it's a vinyl window. This is another casement window. You can see, if you look at this, how much larger this window looks compared to that small double hung window that was in the dining area. But the crazy thing about it is it's really not much bigger at all. It might be bigger by an inch in either direction, but it feels just so much larger because you don't have all the mumbo jumbo and nonsense that comes along with a double hung window. All right, so we're going to continue to move along here to the next room, and I'm actually going to look at the entrance door. Okay, so now here's the thing with doors. If I come across a door and it has anything more than 50% of its surface area as glass, I am actually going to treat that door as a window and not as a door at all. Okay. Um, Now, in your software program, you might be able to specify out, exactly the surface area of the glass and what kind of door it is, whether it's hollow core, fiberglass, solid wood, whatever. But just as a general rule of thumb, okay, I will take a door. If it has anything more than 50% of its surface area in glass, I will treat it as an operable window, because that's in essence all it really is, right? So yeah, we'll take a look at this and see what we can figure out there. Again, we're going to do the same thing on these. If we can find any manufacturer's name or number, it's great to have that information. And if this is new construction or a remodel, it is very likely that the contractor will have the actual little labels that come on those windows. Don't let them take them off, or at least get the information off of them before they do take them off. So, again, good information to have. So we're measuring this out. Surprise, surprise, it's 6'8". Imagine that. And I believe this door here was 34 inches total wide. So we're going to jot that down. Moving on to the bathroom. Again, this is a standard small bathroom. Nothing crazy going on here. We want to take a look at where we can get air into this room. We're not going to focus on a return at all, because you do not put returns in a bathroom. The only place that the air is coming out of this room is through that exhaust, okay? Because the last thing you want is to have your family over for Thanksgiving dinner and Uncle Jimmy comes over, he blows up the bathroom, and now everybody is sitting around watching the football game smelling Uncle Jimmy and his digested turkey dinner. So, no returns in the bathroom. We just want to look at the supply. Again, that's a very basic small bathroom. The only thing I need to know here is what's above it, what's below it. This particular bathroom is an interior room. So interior rooms don't really need a whole heck of a lot of air movement. But bathrooms specifically, we do have to account for makeup whenever that exhaust is actually running. So, yeah. So that's pretty much it on the bathrooms. As we move along here, we're going to take a look at the windows specifically. Okay, so I'm going to start with the window in what we're calling our master bedroom. I could talk about windows for weeks on end. I have many videos specific to windows, but what I'm looking for here is, because I know that these do not have any manufacturer name, model, serial, any information on them whatsoever. I have looked, I can't find them. I want to get as much information as I can off of the window itself. So I'm going to pull the screen out. We're going to take a look, see what we can find. Now, look at this is a double pane window, but I want you to take note of the actual panes of glass in this window, okay? They do not have any shielding on them. They don't have any reflection, nothing like that. They're clear panes. But also the pane thickness, okay, the actual thickness of the glass and the separation between those two panes is something that I just want to look at. Again, on this project, it's really not going to make a huge difference because we're dealing with a small apartment, less than 1,000 square feet, that has 3 windows in it. Okay, but as we move through, I want you to take a look at some of these other windows and doors at the separation of glass. You will see that this casement window, this is pretty common for a lot of casement windows, to where they will have a much larger pane separation than you will find on a door or even a double hung window. Double hung windows tend to have a much closer separation of panes than a casement window or even a fixed non-operable window. And what's the benefit of that? Well, you get a little bit more argon fill or whatever they're filling the windows with. Let's just hypothetically say that we're just throwing air in there. Okay, we've got a little bit more cushion of air between those two panes. On a project like this, that doesn't mean anything. I've gotten questioned many times. Hey, John, why are you spending so much time looking at windows and doors, looking at how far an overhang is, measuring out to the tip of the gutter? Why are you doing this stuff? I mean, why can't we just do a general rule of thumb? 600 square feet gives you a ton or so. I've heard all kinds of crazy stuff. I'll say that on a project like this, realistically, it probably doesn't matter. I don't need to be looking at pane thickness and separation of panes and stuff like that. You can see right here on this window here, not to jump off topic, but it is much thinner than that casement. But anyway, I've gotten it. And on a project like this, no, it does not matter. But on a larger commercial project where we've got a one level has 120 windows on it, to know that information is very, very beneficial. I mean, it could be the difference between several tons of equipment. If we're looking at, we accidentally thought that they were all vinyl windows and they all turned out to be aluminum or something like that. But I digress. That's another topic. So here we're looking at the actual stickers that come on these windows. If you can get the information on these stickers, great. If you can snap a picture of it, if you can take one of the stickers, if the contractor who bought the windows, okay, so like if it's a remodel or if it's a new construction, every window and door is going to have this sticker on it. And it's going to tell you like, information pertaining to that window. How much reflection do we get? What is the overall, thermal conductivity of that window or door? So that would save you a heck of a lot of time. We can just throw that information into the computer and be on our merry way. So here is another door that I bought for apartment number 2, which I have not worked on yet. But you can see it's a very similar door to the one that we've got in there. But what you'll notice is the actual, what are they called? Like the grids that go in between the window panes. These grids are internal to the panes of glass. So rather than having those grids external to the glass, the benefit to this is, one, you get that larger separation between the panes, so you get more airfill in there, but also they're a lot cleaner. Okay, you don't, when it comes time to cleaning them, you squirt the window down, you clean it off, done. You don't have to deal with cleaning in between all the little grids and getting the cobwebs and dust and all that stuff out of there. So I really do like those types of entrance doors to where they got the grids inside of the two panes. So we've gone through. We're looking at we've done the areas of the rooms. We've looked at the windows. We've looked at the doors. What's next? Okay, we got to look at the walls, we got to look at the floors, and we got to look at the ceilings, okay? So take note, whenever you're looking at the floors, that what the floor coverings are. Do we have vinyl? Do we have tile? Do we have hardwood? Do we have carpet? As much information as you can gather, okay? So that's kind of why I separated the living room from the rest of this, because you'll see that we've got hardwood floors in a large portion of that zone, but the living room is carpet, okay? So that will play a minor role in the heating load of this building, especially because underneath of this, it's a crawl space, okay? Now it is a sealed crawl space, which is what we want, but nonetheless it is a crawl space. Now, this building, it used to be an old grain mill from the 1800s. So those hardwood floors you're seeing there, those are the original hardwood floors to the building from back in the 1800s. I just stripped them down and refinished them because I thought they looked pretty cool. Now, the thing is with these floors, the actual thickness of that hardwood is a true 2-inch. okay? Whereas a traditional hardwood floor that you go to the lumber liquidators or Lowe's, Home Depot, wherever, it's going to be like a 3/4 inch thick, if it's even that, I don't know. And then you'll have a subfloor under it. We don't have that here. This is the floor. What you're seeing right there, you've got 2 inches of slab, and that's it, okay? Now, under this carpeted area, what I'm pointing at here, this whole cutout, this wall used to be a cutout where there was a barn door. They used to actually back the wagons in right there. So where this carpeted area is, that floor was non-existent at one point. It was actually a lower portion. That was the driveway coming into the grain mill. So this area has a traditional floor. Now, the benefit to having a traditional floor is you can go in any one of your software programs and it's going to have a traditional framed 2x8, 2x10 floor with R19, R21 insulation, carpet, and you're done, okay? But like that grain mill floor, that hardwood, you're not going to find that in your program. I can guarantee it. Any program that I've dealt with, they don't have grain mill floors in there. So this is where coming back to your actual manuals and knowing how to calculate the thermal conductivity of a material really will benefit you, because we're going to need to know that. Again, on a small little area like this, it's not going to be a deal breaker between a 2-ton and a 2.5 ton. But if we were dealing with a 4,000 square foot building to where half of it had this type of floor and the other half was a traditional carpeted framed out floor, it will make a difference, especially in your duct calculation. So take note of all of your floors, okay? Now this is where we would crawl under the house or go into the basement and take a look at how thick the floor is, okay? So is it a 2x12? Is it a 2x10? Is it a 2x8? We want to know what that is, okay? How much insulation do we have between all of those floor joists? Did they put any of that fluffy stuff in there at all? Okay, so if it's like to a conditioned basement, the chances of them insulating that are pretty slim. So you will want to take note. Now, I do know here that, believe it or not, I don't know how, what the thought process was back in the 1800s, but these joists are spaced out on a 18 and then 20 inch and then 18 and then 20 inch spacing. The joists themselves are not a traditional 2x12, okay, to where it's 1.5 inch thick, 10 3/4 inches, deep. It's 3 inches thick and a true 12 inch, overall height. So this floor is not going anywhere anytime soon, but the way that they insulated it, because you can't get like an 18 inch, insulation roll, there are some gaps in between the insulation and where it butts up to the actual joist member. So, take note of it, especially on like an old floor like this, okay? Whenever you're dealing with a, unconditioned crawl space below, it all, needs to be accounted for. So that's pretty much the floors in a nutshell, okay? We want to, again, get the areas of the floor, know the materials on the floor, know how the floors are built, the thickness of the floor, if there's any insulation, and you're golden, okay? So once you've done that, then we're going to move to the ceilings, okay? Now, with the ceilings, is this like the first floor and is there a second floor above it to where that would be considered a partition ceiling? Okay, partition ceilings do not give for or do not allow for a major variance between levels in terms of temperature. Okay, so that's something else to consider there. Oh, I almost forgot. Yeah, so whenever we're looking at, I'm going to back up here, the crawl space itself. Now, this particular crawl space we just think back to how the place is built. Okay, so we've got a footer, we've got our grade in the crawl space, we've got our foundation wall, and then we've got our sill that runs around, or our rim beam that runs around the whole perimeter of the building. We've got our joists that run across, and then we've got the fluffy stuff in between. So that's your traditional way of building a floor. Now, what we need to take note of, especially in an area like this, which was an old commercial building, is where is our exterior grade? Okay, is that grade, 3 feet below the floor? Is it 6 inches below the floor? How much exposure does that crawl space foundation have? Okay, this would be true whether it was a full basement or if it was just a crawl space. We need to know the exposure that there is on our crawl space itself. Now, one place where this will really come into play is whenever you've got an exposed or a half basement, to where one half of the basement is dug into the wall and the other half is completely exposed. I have family that lives in the hills of West Virginia, and you ought to see some of the houses down there. You'll have, if you look at the house from the road, you'll have just it looks like a rancher house. Okay, then you go around back and you'll see that the house is actually 3 stories deep, where 2 stories are completely buried into the hillside, and you've got 3 exposures on the backside of that building. They are literally building their homes into the sides of a mountain. It's actually pretty amazing to see, but you would want to know that whenever you're going in, because you're not going to treat that basement as a completely dug in basement, and you certainly wouldn't treat it as a complete exposure. So know what you're dealing with there. Now we're moving on to the ceilings finally. So what do we got above here? Now on this particular apartment, we've got an attic space. It's unconditioned space. Technically it is a vented attic, and there's nothing but a 6-inch layer of insulation above this drywall here. You can see those beams that keep running across the apartment there. Those are the beams which actually hold up the ceiling itself. Okay, so you've got that beam. Then they actually have just 2x6s that run perpendicular to those beams, and the drywall is just hung right onto that. So I wouldn't go up here doing jumping jacks or anything like that, but that's all we've got in terms of thickness and insulation. Now, one unique thing about this building is you can see here over the dining and kitchen area, we've got this open loft type of situation. Now, you can see that catwalk that runs across there. That's pretty cool. It actually used to be where they would run. They used to have a track system that ran across that catwalk that ran the whole length of the building from front to back. And there was a cart up there to where they would have it filled with grain, and they would either unload it from a wagon or load it out the back. There used to be a door right there that is now covered up that they would dump into a wagon. The catwalk is still there. It's obviously unoperational at this point, but what we need to know is we've got all this additional volume in our kitchen and our dining area that we have to contend with. This is all air that needs heated and it needs cooled, and we need to circulate this air through our building as well. So you will see that at one point they had a return that was kind of stabbed in there up on the right hand side, and that was pulling air from that area. It would take it down to the furnace and just help to recirculate this area here, which is good. That's what we want. We also want to make sure that we're keeping this in our calculation, all this volume up here, okay? Not that it's a huge amount of volume, but I will tell you, it gets hot. If you're standing on that catwalk up there in August, it is hot, okay? I don't think that there's a whole heck of a lot of insulation sandwiched between the drywall and the underside of those shingles. I can tell you that right now. There's not a lot. There's not a lot of air movement up there. there's not a lot of insulation, it gets toasty. So we want to know that. That's a good question to ask the homeowner. Do you have any area in your house that gets like abnormally hot? It's pretty cool whenever you go through some of even these new homes that have been built within the last 20 years. You go through with a thermal imaging camera and you can see where where every corner was cut when it came time to insulate. My parents' house, it's a newer home, and you can see where the crew was finishing up their insulation on Friday afternoon because, well, the insulation's just not there. So, yep, that's that. Now, here what we're looking at, this is, again, this right here, what I'm talking about is a video series, the overhang that is over a window. We want to measure a few things right here. We want to measure the distance from the wall face that the window is mounted on all the way out to the tip of the gutter, okay? And we also want to measure the distance from where the soffit meets the wall vertically down to the top of the window, okay? We want to know that information for our summertime whenever we're considering our solar gain on these windows. Where I'm at here and that window that we were just looking at, that is in a southwest position of the building. So it is very important that we take those measurements. We get a lot of solar gain, especially on that window right there. Whenever, it's 3-4 o'clock on a summer afternoon, that window is in full exposure. So I take those pieces of information down. We're going to put those in the computer as well and figure out, our solar exposure. And we can determine how, exactly how much BTU gain we're getting through that glass because of it. So now this is kind of one of those things you got to take, feel your customer out. Okay. If this is new construction, it's not a problem. But if you got a tricky area in a building, take a picture of it. Okay. Now I wouldn't be just going around their house snapping pictures of all kinds of stuff, because they might get a little weird that you're just walking through their bedroom taking pictures. But get their permission. If you've got a weird area that you want to remember whenever you're actually back in the office doing your job, snap a picture of it. Okay. So let's move on to the kitchen. Like I said, kitchens are fun. I love doing kitchens. As a matter of fact, this is a whole nother video about kitchens. I have one on residential kitchens, and I have a whole series of videos on commercial kitchens. Kitchens are an animal in themselves because they, like I said, this is where everyone's hanging out. So we've got a high latent load. We've got a high load from all the people in the room. We have we've got nice big ovens. We've got cooktops. We've got microwaves. We've got these big double, reach-in freezers and refrigerators that off the back side of them have these condenser coils that are just dumping heat into the area. There's a lot of heat that is generated in a kitchen, and there's also a lot of lights. Okay, so that's something else we got to look at. How many lights are in these kitchens? They all are burning heat. So as we move through here, we're going to take a look. What complicates a kitchen is there's generally not a lot of places to put your supplies. Okay, so what do we do in kitchens? Well, we could do toe kicks, which I opted to do here. We did one toe kick that's blowing out into the center of that kitchen space, and it worked fine here. Okay, now what else could we have done? Well, we could have put a traditional 4x12 on either side of the refrigerator. Do not put your supplies in front of the refrigerator. Do not put your supplies in front of the dishwasher, and do not put them in front of the oven, because when it comes time to replace those appliances, they're just going to get smashed up, and you're really going to make somebody unhappy. I can say that. I've been in homes where they have stuck a floor register, either right in front of an appliance or right in front of a door, and it's all smashed in. And what good is it doing anybody at that point? So be mindful of where you're sticking them, okay? Now, we are finally going to take all this information and we're going to go back to the office and see what we can figure out.
Anything else? Let's go run some numbers. Alright guys, we are finally back in the office after a long hot summer and a long time away from this specific project. So let's get going. What we're going to do is we're actually going to chop this up into a few different videos. I wanted to make one video doing the site visit, load calculation, duct design, the whole 9 yards in one video, but I just simply cannot do that. It'll be way too long. So we're going to chop this thing up. What we're going to do, just finishing this video up, we're going to look at the basics of the load calculation. We'll do another video on a full load calculation, then another one on the duct design. So bear with me, we're going to get through this, but it's going to take a while. So I have got my sealed architectural drawings here from the straight off the press from the architect, and we're going to take a look at this. Now, because I am not endorsing any specific manufacturer's software, unless somebody wants an endorsement, no, I'm not going to go into the software at all, okay? We're going to look at this as if you went on Amazon or you went on ACCA's website, you bought the Manual J load, or the Manual J manual, yeah, and you went through this thing, pen and paper, calculator, and we're figuring it out that way. So let's take a look. The very first thing in doing a good load calculation is knowing where you're at, okay? If I was to take a spec-built home and put it in Savannah, Georgia, I'm going to have a way different design than if I took that spec-built home and put it in Buffalo, New York, or if I took it to Boiling Springs, or if I took it to Green Bay, or if I took it to Sacramento. I mean, they're all going to be different. So we need to look at specifically where this building is going to be located. And then after we have done that, then we're going to look at the orientation that the building is on the site, and then we can finally start diving into the actual construction of that building. So to start, Manual J. Even if you're in the abridged version of this book, a lot of that will be covered in here. You don't need the full version, but there's some things that the full version has that the abridged version obviously is not going to have. So we're going to open up to the 1A. That is the first place we're starting. So table 1A looks like this, okay? It is several pages long, and it goes state by state, city by city, has airports in there, and what this does is it takes all of our outdoor design conditions for wherever we're working, okay? So let's just say that I'm going to open up to a random page here. We are in Indiana, okay? Now, I worked briefly in Indiana a few years back, and, Indiana's an alright place, but it's very flat. Anyway, I'm going to pick a random place, Hobart. I've never been to Hobart. I don't know where Hobart is in Indiana, but as we find our closest location to where we're building our site, we're going to go across this this whole table here and look at all of these different columns, and we're going to start entering those either in our software. We're going to be writing them down on our pen and paper, because these are going to give us our overall building heating and cooling loads based on these numbers. So the very first one is our elevation. Okay, so that lets us know how high above sea level we are. For like this psychrometric chart that we've got back here, that is all based on sea level. You get above sea level you have to account for that, okay? Now, if you are, you know, a couple 100 feet above sea level, you know, to account for that is, you know, a drop in the bucket. But when you get, you know, a few thousand feet above sea level, the air is going to definitely react much differently than it would down at sea level. So if you're in Colorado, up on top of the mountain there, we're going to be designing our systems way differently than we are if we're in Miami. So Hobart, they are 644 feet above sea level. So do we have to make any major corrections? Nah, we don't have to. I mean, if we want to split hairs, we can. There is a correction, you know, an altitude correction formula, which I'll throw up on the screen. But, you know, if you wanted to split hairs, you could. So we've got first column, elevation. Next column, we've got our latitude, degrees north. And what that does is that takes into account when we're looking at our fenestration. So how the sun and the effects of solar radiation, you know, interacts with our building through the windows, okay? So it, you know, our software programs will take into account where the sun is based on our degree latitude throughout the day, so it knows how the sun is hitting the actual window based on our overhangs and everything like that. So that our latitude degrees north, that is what that's what that number is all about. You know, I don't think that software programs will take this number in account too much when it comes to temperatures, okay? Because if you look at a, you know, mean temperature graph across the United States, it wows drastically, and it, you know, the latitude plays a much less role in our climate when compared to altitude and actual weather pattern. So that's what that's about. Third column over is our heating 99 outdoor dry bulb. So what this number here represents, so like for Hobart it says 2 degrees. That is what we are going to be sizing our heating system off of, regardless of what heating system it is, gas, oil, you know, if it's a boiler, if it's a furnace, heat pump, whatever. This is the number we will be sizing it off of. Now, again, I've never been to Hobart, but I would have to assume that it gets much colder than 2 degrees there, okay? So like a place that I'm familiar with, we'll go to Pennsylvania here, where I size a lot of my equipment is either in the Chambersburg, the Harrisburg, or the York, you know, regions. We have usually between, you know, 12, 13 degrees that we're sizing our 99%. So what that number represents is 99% of the hours in a year, it is going to be above whatever this number is. However, obviously, 1% of the time, you're going to drop down cooler than that. So I do know that here we experience a few hours throughout the year where we dip into the single digits. We get even sub temperature whenever we've got, you know, wind chill and all that. I am not going to size my furnaces based on the 1% of the time that it is below 12 degrees. Because if I do, then 99% of the time the furnace is oversized. And we don't want to do that. Same with, as we move on, we're looking at the cooling, okay? So if we're going back to Hobart, Indiana, 2 degrees. That's what we're going to be sizing our furnaces off of, even though I'm sure it gets colder than that. So the next, I think, 5 columns, 6 columns deal with the cooling, okay? So it takes into account not only that sensible temperature, but all the latent loads that are associated with the summertime. We're dealing with a lot of humidity. So we've got our, in that the first column of this cooling area, the 1 degree dry bulb temperature. So just like our 99 in heating, we're dealing with our 1% dry bulb temperature for our outdoor condition in cooling. Hobart, Indiana, 88. And again, I'm sure that even today, it's probably hotter than 88 degrees in Indiana, in Hobart, Indiana. I know we are experiencing a heat wave here in Pennsylvania today where the heat index is over 100. I'm not sizing my air conditioner for 103 degrees because that's where my heat index is today. I'm going to size it on the 90 degree outdoor that Pennsylvania, or where I'm at here, is our outdoor condition is set. So Hobart 88. That's where we are going to be sizing our air conditioner. Now, if I wanted to make everybody happy on the July 4th weekend, whenever you've got all your brothers and cousins and uncles over, yeah, we can size it for 100 degrees because at one time that when everybody's in the house, it's 100 degrees and you got all those people moving around in there. But 99% of the time, that air conditioner is going to be way oversized. And oversizing an air conditioner, well, I mean, it's not good. So we've got 88 in Hobart. Now we've got in the next column over, we've got the wet bulb temperature that is associated with that dry bulb. So if we go to our psychrometric chart and we look at 88 dry bulb temperature with a corresponding 73 degree wet bulb temperature, it's going to give us a humidity. It's going to give us all of, on the right hand side there, what our grains of moisture are within that air. It gives us almost every other parameter to look at what the BTU per pound of outdoor air is, and that's what we're going to be sizing our air conditioner off of. So that other point on the psychrometric chart is going to give us every other parameter for our software, for us, whatever, to size our systems off of. So that's what we're dealing with in Hobart. 88 dry, 73 wet bulb. Moving over, we've got 3 designs for what we want our indoor conditions to be. Okay, so typically, well, that's another video for another day. Typically, you're going to want to have your indoor conditions somewhere around 70 to 75 degrees at a given humidity. I wouldn't want to have an air conditioner where it is 68 degrees in the house, but I go in there with a psychrometer and see that it is 68 degrees. Well, that feels good, but it's 78% humidity in the house. That does not feel good. I don't care how cold it is in the house. I don't care what the thermostat is physically reading. If your humidity is way too high, it's not comfortable. I don't care. So we've got 3 columns here to which we are going to be looking at sizing a system based on the humidity. Okay, so we've got a 55 relative, a 50% relative, and then a 45% relative humidity. I usually will err on the side of caution and try to size for a 45% relative humidity. If, like at my house for instance, if my thermostat is reading 76 degrees, I can bet you that I'm probably comfortable because my relative humidity is low. It's probably sub 45, relative humidity. I don't want to go too much lower than that, but if I'm like 43, 46, 47% in that range relative humidity, I am very comfortable, regardless of whatever the temperature may say. So these next few columns here are going to be associated with that. And then our last 2, we've got our daily range, which is going to be a high, medium, low, and that basically how much swing do we see throughout a given 24-hour period in a specific location. So you might see that if you're at a higher elevation, Idaho for instance, okay, they will see a much higher swing where it will be 38 degrees in the morning when you wake up, your furnace is running. By 2 o'clock in the afternoon, the temperature starts rising to where your air conditioner is going to kick on. And then at night it's going to dip back into the 40s, and you're going to see these huge swings within a 24-hour period. Whereas if you are maybe at the beach, okay, or even where I'm at here, we don't see a huge swing. Sacramento is a good one. I was in Sacramento a few years ago, and
it was amazing. Like the temperature stayed pretty much constant. You know, it did a little bit of swing throughout the night and throughout the day, back and forth like this. That's a very low daily range. So that's what that's going to be. And then our very last one is our ratio. So we've got our heating degree days over our cooling degree days. I will look at this number here whenever I am considering, is a air source heat pump a good application for this particular area. Where I'm at here in Pennsylvania, you know, we're kind of like the cusp of efficiency when it comes to air source heat pumps. Now there are some brands of air source heat pumps that I'm much more confident in putting in, for a specific place as a air source heat pump. And then there are some that I just don't. But whenever I get blueprints from all over the country, this number I will look at, because I'm not too exactly familiar with where you live. Is an air source heat pump a viable option? You're going to see this ratio number here. I just know for me what I've kind of looked at as time has gone on, where the if you've got a really high number to where your heating way outweighs your cooling, in terms of BTU in a building, you're obviously not going to want to put an air source heat pump in there, because if you put an air source heat pump in there that is sized that it will maintain your heating load, when it comes to kick on for cooling, it's going to be grossly oversized. Now, if we size it for cooling to where it maintains itself very well in cooling, and then when heating season comes around, your heat pump is going to be grossly undersized, and then you're going to be relying heavily on that backup, the backup heat source, whether it be electric, propane, whatever. So that's something I want to look at there. Every area is going to be a little bit different, but so look at your ratio between your heating degree days, your cooling degree days, and you will get an idea of that. So that information there, you will put into your software. You will, put on your paper, whatever. But this is the very first thing that you have to do. Okay. So after we have done that, I will take a look at whatever my architect has given me, and I will start going through the building and figuring out how much heat loss and gain that we have in any given area of the home. So for the sake of, if I have somebody who calls me up and they want just a quote or an estimate for a system, I will just do a block load really quick, kind of get a general idea of what equipment will go in there, a rough idea of the ductwork, and give them an estimate. If we're on the same page, then I'll go through the entire process of room by room calculation, figuring out how much BTU this room right here is losing through the windows and doors and the floors and the ceilings and everything else. And that's what we're going to do here. So, like I had said whenever I was in that apartment, I spend a lot of time on the windows and the doors, and maybe it's to excess. Okay, so like for a small apartment like that, yes, it is way overkill. But whenever I'm working on a commercial building to where I've got 110 windows, all facing south, to miss something, miss a detail on a window, or accidentally put it in the system wrong, will greatly skew what heating and cooling equipment will end up in that area. So all of those things that I was talking about whenever I was in the apartment, those come into play here. Your window calculations and your door calculations will generally take up the most amount of time if you're doing it by pen and paper. There was a time where that's what I did. I did everything by pen and paper before I had software, and it takes time. Once you get in the hang of it and know exactly what numbers you're typically working with, it's not too terribly bad. But like whenever I was in college, we were forced to do it pen and paper. Just if you can do it this way, pen and paper, then you can
be thrown onto a software program. It's not true the other way around, to where, well, I mean, really short story, I worked for a company a few years back, to where they had a lady in the office who was trained by the local utility. They were given some, I can't even remember what software it was. It wasn't like one of the big name brand softwares that you're all familiar with, but that's what they were sizing all of their systems on. She went to a one-day crash course on how to do a load calculation and duct design for all of their customers, and that's what she did. That was her job in the office. Needless to say, she could do a load calculation for a building. We would get prints for the job site, and they were wildly inaccurate. So, you know, that's that. So I'm going to look at, if you remember, the bedroom, which was down here that we were working in. It had the bigger casement window. We're going to look at that window first. So if we go back into our manual, I think it's 2A, where the windows start. Let's see here. 2A. Okay. 2A. This is where our all of our window data is stored. Okay. This is where we're going to start looking at the windows. If you remember, we had double pane windows in there. They were operable windows, and they did not have any, they were clear glass. They didn't have any like low-E. They didn't have any reflection to them. They were a very basic window. So what we would do is we'd go down through this chart here, and we would look at all of these different glasses to see what would fit us the best. So we go down, we see a double pane operable window. Then we move right across the chart, and then we can look at different types of construction. Okay, so we've got metal, we've got wood, we've got fiberglass, we've got all these different types of window. We have vinyl back there, so we go down the vinyl column, and it will give us a U factor for that particular window. Now, that U factor, you might, if you had the stickers that came on the window, you've already got the information there, so you don't even have to go in the book. Okay, you can take that U factor and boom, you got it. You can plug it into your software, you can put it on your paper, whatever. So for these windows here, they should be like a 0.5 something, 0.57. Okay, I think the one window I showed you was like a 0.55, 0.53, which is, yeah, that's good. So the we take that number there, put it in the computer. After we have taken that number, then we would go to, I believe it's 3A, or 3B, or 3A, and then we would take a look at our cooling heat transfer multiplier for that particular window. Okay, so like I said, once you get these windows done and out of the way, that's that's the hardest part. Doing the floors and the doors, or the walls and all that stuff is easy. But you'll get a heat transfer multiplier, and what that does is that's a number that takes into account the orientation that window faces. So whether it's facing north, northeast, west, southwest, south, whatever, and it will give a number associated with it based on whatever your air conditioning cooling degree difference is. So you would take, I know it's hard without actually showing you software, but so whenever we went back into that table 1A, we had, for instance, table 1A. Where do we want to work? We'll work in Hobart, Indiana. Hobart, Indiana. Okay, there we are. We've got a 1 degree dry bulb of 88 degrees. So like I said, we were going to take that 88 degrees and jot it down on our piece of paper. Now, this is after you're having a conversation with the homeowner, the builder, whatever, and you've determined what your target set point is for the house in the cooling mode.
what do they want that house to be at? Do they want it to be at 75 degrees at a moderate to low humidity? That's comfortable. Do they want the house at 70 degrees? Do they want the house at 62 degrees? Like, do they want to be able to hang meat while they're watching TV? They can hang a cow quarter and have it not rot away. If they want to hang meat in their living room, that's fine. I can design a system for that, but that's something that I need to know right now. Because I'm going to take this outdoor drywall temperature, I'm going to subtract from that whatever our set point is on the inside. Now typically, we're shooting for like a 70 to 75 range, and that is what we will then use as our use for our cooling heat transfer multiplier whenever we're determining what the temperature difference is between the inside pane and the outside pane of glass. Okay, so a typical heat transfer multiplier might be 15, might be 20, somewhere in that range. Now once we're in this table 3A, we can take that heat transfer multiplier, that number, and go down, and we'll get several numbers associated with the orientation of that window. So we would take all that information and jot it down on our piece of paper, right? So from there, again, like I said, you would need to know what the overhang is on the window, how far down vertically the window is from the corner of that soffit, because we need to see at how much of the bottom of that window is going to be in direct sunlight, and from there we can determine how much actual solar gain we get into a house. If we are designing a passive house to where we want a lot of solar gain on the southern exposed windows during the wintertime, this is where it all comes into play right here. If you are down south and obviously you do not want a lot of southern sun exposure, at least on your windows, again, this is where it comes in. We can create a nice big overhang, some sort of shading, whatever, and we're not going to be letting a lot of solar energy into the house. On this table 3A, this is where you have to determine what we have inside of that window, or I guess outside, but for the sake of this book, they're looking at the inside. So you're going to see 4 different categories here, to where we have no internal shade, we've got vertical or horizontal blinds with slats at 45 degrees, we've got a drape or a roller shade half drawn, or we have a fully drawn drape or shade. Now, if I go into Mrs. Smith's house, and I'm not going to ask her, okay, so Mrs. Smith, at what degree are your blinds going to be drawn during this? I don't care, okay? I am actually not even going to worry about internal shading at all, because I'm not going to size my system assuming that Mrs. Smith is going to have her drapery half drawn, or her Venetian blinds set at a 28-degree angle, and then she goes in there and opens everything up. Now her air conditioner is undersized, and now I look like the bad guy. That is negligence on my behalf, so I do not mess around with internal shades unless I know for a fact that the window is going to be covered. And if that is the fact, why do you even have a window at all? Okay, so this is where you would look. Okay, do we have Venetian blinds in there at a 45-degree angle? Do we have a drape? Whatever. This is where you'll find that information, and that is what you'll put into your software or computer program, paper, whatever. So once you've gotten all of that, you've established which way the window is facing. If that window is facing south, we would then take the heat transfer multiplier for a south-facing window that has no internal shade, that is a double pane, argon-filled window, vinyl frame, and we will multiply that times the square foot area of that window. Gosh. If you can't figure it out by now, having software saves a lot of time. Now we are just, we're just dipping our toe into some of these calculations, and actually I'm not even really getting into the actual calculation of it. I'm just walking you through what a process might look like. So now that we have a heat transfer multiplier for this specific window here that faces south, now we're going to multiply that times the area of the window. We will get the BTU of exchange in the summertime for that particular sheet of glass. We're going to continue to do that for every piece of glass in the building. Sounds fun. So that's cooling. Then we're going to go ahead and do it again for the heating side, because we need to know our heating and we need to know our cooling. Okay, so you're going to get two numbers for every window and every door in the house. So you've done your windows now. Now we can move on to whatever. If you want to do doors next, we can do doors. Doors are not as hard because we're not dealing with everything that's involved with the glass. Once we start dealing with opaque, panels that the sun isn't actually coming through, things really speed up. But like I said, if you've got a door that has more than 50% of its surface area as glass, I treat that as a sheet of glass. So we're going to be doing this whole process. If you've got a sliding glass door, that is an operable window. It is not a door. Okay. If you've got a front entrance door to where it's got 3/4 panel in there of glass, that is a window. It's an operable window. It is not a front door. You'll treat that just as we did here, table 2A, table 3A, and so on. So you can do the same process with all of your doors. I went through and figured out this window here. Let me see if I still have it up here. I'm not even sure if I do. This window in that bedroom had a a BTU loss of 200, just over 250 BTU per hour, and a cooling gain of just shy of 170 BTU per hour. So that's what we're looking at for that window. Now let's just hypothetically say that we rushed through our site visit and we didn't take note to whether it was a vinyl or a wood window. Does that really make a difference? Well, vinyl and wood, not a huge difference, but let's just say it was vinyl versus aluminum. Now, like I said, in residential, I don't see a lot of aluminum windows, but if we did, accidentally put vinyl into our calculation when it was in fact an aluminum window, what does that make a difference? Well, that almost doubles your heating BTU and takes your cooling and it multiplies it twofold at least. So we're looking over 400 of a cooling gain or a heat gain on that building, and for our heating side of it, our heat loss, we're looking at 400 and some BTU per hour heat loss on that one window because it was an aluminum frame. So yeah, that's that. Now we're going to go through, we're going to look at the walls, we're going to look at the floors, we're going to look at the doors. All of that, as you move through these tables, you're going to find them. So like your table 4, that's where you start running into all of your your actual constructed members of the house, like your floors and your walls and everything like that. All of the pieces in this building will have a construction number associated with whatever it is. Now I will write that down just so if I ever need to reference it, I will have that number on hand. So like if we're looking at a 2x4 framed wall with R15 insulation in it, it's going to have a 13D-20C construction number. Then from there you can specify exactly what that means. So that would be a 2x4 studded wall with vinyl exterior and R15 fluffy stuff, no board insulation, so on and so forth. So that is all of that. You can do, if you wanted to, you could go into Excel and you could make a spreadsheet to kind of speed this process up. You could keep your common construction material on a drop-down box. You could have the U values saved to it, so when you bring up a drop-down, it automatically brings up the U, and then it adds up all those U's and does all the calculation for you. You could also, I think you can download it. It's a speed sheet from ACA that is, it's all about the, what we're talking about here. And, it'll give you a gross heating and cooling number. Now, the thing you got to be careful with when you're using these speed sheets are that if you forget a component like a ceiling, well, it's not going to put it in there for you automatically. It's not going to bring up an error code like saying, hey, you forgot a ceiling. Okay? Or if you happen to put the wrong component in, because a lot of this you have to really read what these components mean. If you put the wrong one in, it will drastically oversize or undersize your heating and cooling equipment. So be careful with doing it by pen and paper. Make sure you know which construction component you're actually working with. So we've gone through, we've figured out the windows, we figured out the doors, the floors, the walls, the ceilings. Now ceilings you got to be careful with too, because ceilings, not all ceilings are created equal. The ceiling that we had in that apartment was nothing more than just beams with 2x6s stretched across them, drywall hanging from them, and some fluffy stuff thrown in between. If you had a attic space above that, okay, is it a vented attic? Is it an encapsulated attic? Does that roof that's on top of that attic, does it have any board insulation on it? Is it metal? Is it shingles? Are those shingles dark? Are they a light colored shingle? Okay, all of that plays into account when we're looking at ceilings. I'm actually going to cut this pretty much short because I don't want to bore the heck out of you. We'll have another video that actually goes through this a little bit closer. I would love to show you some software, but I don't know if I really want to. So yeah, that's that. Now, once you've gone through and figured all that out, you have to account for appliances. Okay, you're gonna have to add so many BTU for stoves and so many BTU for refrigerators. You're gonna have to add occupants to the building. You're not building an empty structure, so you got to add occupants to it. If you're going to have 15 people in this house, or if you're going to have 2 people in this house, it's nice to know that. Generally what I'll do for occupants is I will take the number of bedrooms and then I'll add 1 or 2 to that, and that will give me my occupants. So if I have a 4-bedroom house, I will have 5 or 6 occupants in that building. I'm not going to put 15 occupants in a 2-bedroom house. Although I have seen that. I see that quite often actually. So, yeah, that's that. Like I said, I'm going to wrap it up. Oh, also, I think in the last video that I made, I talked about giving something away. Now, if you are somebody who has just killed an hour of your time and watched my video, I'm very happy about that. But you are also being given the opportunity to win something today. And there's no winning anything. I'm giving away some of these t-shirts. We are getting new t-shirts. If you want one of these t-shirts, let me know. I have a pile of extra large t-shirts. Now, I do not discriminate in who I hire, but I have never hired an extra large person. So if you happen to be brawny and wear extra large shirts, or if you've got maybe your wife wants something to sleep in at night, whatever, I've got a pile of these shirts. I'm gonna say like maybe 10. If the next, the first 10 people to send me an email saying, "Hey, I want a shirt," you can have it. It's a free shirt for you. All I would need is like an address that I can send the thing to. So, 10 people, shirts, and yeah, that's that. I will see you hopefully soon, but I can't make any promises. We're gonna go through some more of this, and I have like hours and hours of video that I have to upload, so that's it. Take care. I'll see you in the next one.